So we've gone through some one-dimensional summaries, and now I want to talk a little bit about some two-dimensional summaries, which include things like scatter plots, but also you can kind of group together lots of one-dimensional plots to look at two-dimensional data, and in particular, lattice and ggplot are good at this. So we can look at scatter plots, smooth scatter plots, and also in looking at greater than 2 dimensions. Then you have to get a little bit more clever in terms of how you present the data, because one possibility, of course, is actual 3-dimensional plots, where you might need 3D a set of glasses to wear them. These are usually not that useful, but I have seen them. You can have spinning plots, which allow you to kind of move the data around in 3 dimensions. These can be useful sometimes. But often the most useful techniques are to take 2-dimensional plots and kind of array them or organize them in a special way so that you can look at a third variable or even a fourth variable. And so we'll talk a little bit about these methods. You can also use things like color and size and shape of plotting symbols to add dimensions to your data. So here's a way to look at 2-dimensional data. I've got, in one dimension, the east-west variable, which is categorical, and in the other dimension, I've got the PM2.5 variable. And you can see that I've got 2 blocked plots, one for east and one for west. And you can see that in the east, and on average, the PM2.5 tends to be quite a bit higher than it is in the west. And so that's a nice summary of these 2 dimensions. Now, in the west, you'll see that on average it tends to be a little bit lower, but all of the extreme values of the distribution, so to speak, are in the western United States. So the west has an average that's lower, but has generally a larger spread. So that's kind of interesting. You can do a similar type of plot with histograms instead. So now I've made a histogram on top, which is the eastern counties, and a histogram on the bottom, which is the western counties. And you see the same basic features. The western counties tend to be lower on average, but they have more extreme values that are higher. And the eastern counties are generally higher on average, but they tend to be, but they don't have those kind of very high extreme values. So of course, one of the easier things to do, the most obvious things to do, is a scatter plot. And here I'm plotting the latitude of the monitor in the county versus the PM2.5, just to see if there are any north-south trends. So as the latitude increases, you're going north. And you can see that there isn't a very strong, particularly strong north-south trend. It does seem that the PM2.5 tends to be higher in the middle latitudes and not quite as high in the upper and lower latitudes. I've added a horizontal dashed line here at 12, so you can see roughly where the National Ambient Air Quality Standard is. And you can see that there are a number of dots that are above it, which are, technically speaking, would be out of compliance. So you can use color to add another dimension. So for example, remember there was the latitude and the longitude and the east-west variable in this data set. And so what I've got on the x-axis here is the latitude, and the y-axis the PM2.5. And then I've added the color, so the red and black dots indicate the east and west variable. And so the black dots are the east counties, and the black circles are the eastern counties, and the red circles are the western counties. So you can see now we're looking at 3 different variables here. Another way to look at these 3 variables is to just make 2 plots. So now I've got a panel of plots. On the left-hand side, I've got all the western counties, and on the right-hand side, I've got all the eastern counties, and I'm plotting them by latitude and PM2.5. So you can see that in both cases, the kind of higher pollution counties tend to be in the middle latitudes, and the northern and southern latitudes tend to have generally lower pollution. This is both the case in the eastern and western United States, so that's kind of interesting. So that's a quick summary of the kind of plotting one-dimensional and two-dimensional data in R, and even using color and multiple panels for looking at 3 dimensions that are greater than 2. And in general, these exploratory plots are meant to be quick and dirty. Notice I didn't spend any time working with the axes or setting the labels, and so I just kind of used the defaults, and for the most part, I used the defaults in R. But the nice thing about exploratory plots is that they let you summarize the data and highlight any broad features in the data which may be of interest. You can explore kind of basic questions and hypotheses. So remember the basic question that we were looking at was, are there any counties that may be out of compliance? And these plots may suggest useful modeling strategies for the next step, which may be a more detailed analysis or model fitting. Lastly, here just a couple of resources. There's a nice website called the R Graph Gallery, which has lots of examples of graphics and plots made in R. And then, of course, the R bloggers website will often highlight lots of plots that people have made and have published through their blogs. So take a look at those to get a sense of what's possible.